students, welcome back. Today we are going to see ICSE syllabus class 8 mathematics session 8. First we see the solution for the assignment problems. These are the solution. So kindly note it down.
Hello students, welcome back. In the previous class we learnt about cube and cube roots. Now today's class we are going to see about a set. A set is nothing but a collection of well-defined objects. The objects are said to be its elements or members.
The object of a set are called its members or elements. For example, the collection of all books in the district central library. The collection of all colors in the rainbow. The collection of prime numbers. These are said to be a sets. Let's see. We usually denoted a set by capital letters of English alphabets like capital A, B, X, Y, Z, etc. And its element by small letters like X, Y, A, E, D, etc. If X is the element of a set A or belongs to A, we write it as X belongs to A as a symbol. This is the symbol for belongs to. If X is not element of set A or X does not belongs to A, we denote it as X is not belongs to A. Next, we move on to the representation of sets. A set is usually represented either in the tabular form or in the set builder form. So, the tabular form is otherwise known as a rostered method. In this method, we represent a set by listing all its elements between brackets or curly brackets. No elements are repeated while writing a set by in rostered form. For example, the set A of all the vowels of the English alphabets is represented as capital A is equal to A, E, I, O, U. Next, we move on to the rule method. In set builder form, all the elements are described by a rule. For example, A is equal to X is a vowel in English alphabets. Likewise, A is equal to X on to X is an prime number or X is lesser than 15. Some special sets are if they denoted that capital N, then it's said to be a natural number like 1, 2, 3, etc. In the same way, if they denoted W, which is nothing but a whole number from 0, 1, 2, 3, etc. If they denoted X or I, then it's said to be an integers. It may be a positive or a negative like a -2, -1, 0, 1, 2, 3, etc.
Let's see an example for idea of sets. From this first example, they given that write each of the following sets in the roster form. They given that the set of the month in a year that ends in the letter Y. So we know that we have 12 months. In these months, which are the months are end with Y? Yes, they are January, February, May and June. So these are the set. We write it in the roster form. Next we move on to the next thing. So from this they given that X is equal to N divided by 2N plus 1, where N belongs to capital N and small n is lesser than 4. So from this they given that N belongs to natural number. The capital N is denoted natural number. So the natural numbers are 1, 2, 3, 4, etc. So they also given that condition that n is lesser than 4. So it's not equal or greater. So it is a lesser than 4. So we consider the n terms as 1, 2, 3, not 4, because they given that lesser than 4. So now we find the n terms. Now we going to substitute in this. So we get n is equal, we substituting n is equal to 1, 2, 3. So we get x is equal to 1 by 3, comma 2 by 5, comma 3 by 7 respectively. So therefore given set is 1 by 3, 2 by 5, 3 by 7. Next we move on to the second example. So from this example they given that express each of the following sets in the tabular and set builder forms. So from this first we going to find the set E of even natural numbers. So they given that it is the set of even natural numbers. So the even natural numbers are 2, 4, 6, 8, etc. So this we write in the tabular form. Next we going to find next we going to write in the set builder form. So even means what? Some number which is multiplied by 2. So we write it as x is equal to 2n. So n is belongs to capital N.
Now from the second example, they are already given in the tabular form. So now we are going to convert into a set builder form. So let me consider it as x. So x is equal to n is whatever the value we taking. When we add 1 we get 5. So let me take it as x is equal to n divided by n plus 1, where n is belongs to capital N and 4 is lesser than or equal to n is lesser than or equal to 9, which means from this they given from 4 to 9. So let me consider it as 4 is lesser than or equal to n is lesser than or equal to 9. Next we move on to the types of sets. In this the types of set, the first type is finite set. In the number of elements of a set is finite, the set is called a finite set. For example, the set of family members, or x is equal to x is a factor of 6. So these are the example for the finite set, which is nothing but we know how many things in the set. Infinite set is nothing but a set that does not have a fixed number of elements. Is called an infinite set, which is known as a set is uncountable number of elements. For example, a set of all positive integers. We usually know that the positive integers are goes on from 1, 2, 3, etc. So this is not it is not countable. So it's said to be an infinite set. The next example is the set of integers, that is -2, -1, 0, 1, 2, etc. So these are the uncountable numbers of elements. Next we move on to the next type, empty set. In the name itself we know that the set doesn't have any elements. It's said to be an empty set. We denote the empty set as empty curly bracket or this symbol. So the empty set is also called a null or void set. For example, a set of odd integer with 6 as a factor. So we know that 6 has no odd integers. So the set is an empty set. Next we move on to the next type, singleton. A set that contains only one element is called a singleton set. For example, a set 0 and another example is set A. So these are said to be a singleton set. Next we move on to the cardinal number of a finite set. The cardinal number of a finite set A is the number of distinct elements in the set A. It is denoted by n of A. Example for cardinal set of a finite set is if A is 2, 3, 4, 5, then n of A is equal to 4. Next we move on to the next type, universal set. A set which contains all the elements of all the sets and it is denoted as U. If A is equal to Earth, Mars, Jupiter, then the universal set U is the planets of the solar system. Next we move on to the equivalent set. Two finite sets contains the same number of elements. In other words, the sets A and B are equivalent sets. If n of A is equal to n of B, we express this in the symbol as A is equal to B or A into B. For example, if A is equal to 1, 2 and B is equal to A, B are equivalent set because n of A is equal to n of B is equal to 2. Therefore, it is an equivalent. Next, we move on to the subsets and supersets. The subset is nothing but if A and B are two sets such that every element of B, then A is an element of B. We say that A is a subset of B or A is included in B. We express this in the symbol as A subset B. If the set A is not a subset of the set B, we write A is not a subset of B. For example, 1 is a subset of 1, 2, 3. In the same way, 2, 4 is not a subset of 1, 2, 3. If the number of elements are the cardinal number of a finite set A is n of A, the number of subset of A is 2 to the power n of A. Next we move on to the proper subset. If the sets A and B are such that each element of A is an element of B, but B has at least one element which is not an element of A, then A is a proper subset. For example, if A is equal to 1, 2, 3 and B is equal to 1, 2, 3, 4, then every element of A is an element of B, but the element 4 of B is not an element of A. So we represented as A is a proper subset of B. If A is a finite set containing n of A elements, then the number of proper subset of A is equal to 2 to the power n of A minus 1. For example, the proper subsets of set A is equal to 1, 2. Or we say it as null set of 1, set of 2. So A is equal to 1, 2 itself is a subset of A, but not a proper subset. Therefore, the number of proper subset of A is 2 square because it consists of 2 elements. So the n is 2. So 2 to the power 2 minus 1 is equal to 4 minus 1 is equal to 3, which we get that null 1, 2 Next, we move on to the superset. Let A be a subset of B. That is, A is a subset of B. Then we say that B is a superset of A. We express this in a simply as a B is a super subset of A. For example, if A is equal to 4, 6, 8 and B is equal to 2, 4, 6, 8, 10, then B is a super subset of A. Next, we move to the equal set. Two sets are said to be an equal if they contain the exactly same element, otherwise they are said to be unequal. For example, if A is equal to 2, 4, 6 and B is equal to 6, 4, 2. So the elements are same, but they are exactly contains the same elements. A and B are equal, so it's said to be an equivalent set. Otherwise it is not an. So from let's say an example, if P is equal to a letter of the word blame and Q is equal to a letter of the word meal, then identify the true or false statement. So from this they given that P is equal to Q. So from this they given that P is equal to blame BLAME and Q is equal to meal MEAL. So from this statement P is equal to Q is absolutely false, because B is belongs to P but B is not belongs to Q. Therefore it is a false statement. The next thing is Q is lesser than or equal to P. So from this Q is a subset of P. Yes, of course it isn't true, because all the elements in the Q are in the P. So we denote it as Q is a subset of P. The next statement is Q is into P. So from this statement is false, because in this we find that n of P is equal to 5 and n of Q is equal to 4. So therefore it is not equivalent. So therefore it is false. Now let's see another example. In this they given that if the universal set of U is equal to 1, 2, 3, 4, 5 and A is equal to x onto x is a prime factor of 420, then write the set A is the tabular form. Also write all the subsets of A which are singletons. So from this now we're going to find the tabular form, and also we're going to find the subset of the A. So therefore we in the previous class itself you learned how to find the prime factor method. So now we're going to find by using the prime factor method. 420 is divisible by 2 and 210 is divisible by 2. So we get 105. 105 is divisible by 5. So we get 21. 21 is not divisible by 2. So we go for 3. So we get 7. So 7 into 7. Therefore we get 1. So 7 is divisible by 7. We get 1. So 420 is equal to 2 into 2 into 3 into 5 into 7. So therefore A is equal to 2, 3, 5, because 7 is not belongs to U. Since the question has 1, 2, 3, 4, 5. So 7 is not belongs to U. So we can't include in the A. So the singletons of A are a set of 2, set of 3 and set of 5. Review what we learnt in this class. Now can anyone say define the set? A set is a well-defined collection of objects. Very good. Next, can anyone list out the set of letters of assessment word in a roasted form? In the previously, I said that in the roasted form, the letters are not repeated, the elements are not repeated, so we write it as A is equal to ASEMNT. Okay, now can anyone say write P is equal to January, June, July in a set builder form? So we write it as the set of months starting with J. Next, can anyone say identify the set of all straight lines passing through a point is finite or infinite? Yes, of course, it is an infinite set. So the line goes on. So we don't know how many lines are in the straight line passing through the straight line. So it is an infinite set. Next, verify whether A is equal to 1, 2, 3 and B is equal to A, B, C are equivalent sets. Yes, they are equivalent because n of A is equal to n of B is equal to 3. So therefore it is an equivalent set. Next, find the cardinal number of M is equal to P, Q, R, S, T, U. Yes, the n of M is equal to 6. So the cardinal number of M is 6. So these are the assignment problems. So kindly note it down and submit in the Google Classroom. Students, those who are not joined in the Google Classroom, kindly join. This is your Google Classroom code. Thank you.